Welcome to this tutorial, where I will be building a basic user interface using NoesisGUI and Unity3D. The first thing we need to do is create a new project using Blend. We're going to use the 2013 version included inside Visual Studio. We need to create a WPF application project. We create it in the desktop with the name Tutorial. Once the project is created, we observe that two XAMLs are included in the project, app.xaml and mainwindow.xaml. They are only needed to create the WPF executable. They can be ignored for using this project in Unity3D. What is really needed is create a folder with the name Assets. Inside that folder, we're going to create the Unity project. It is very important to do this step before creating the Unity project because Blend does not allow adding folders that already exist. Once the folder is created, we launch Unity3D, and we open the project corresponding to the Assets folder we created. In our case, it is created in the desktop under Tutorial, and there we have the Assets folder. From this location, we open the project. As you can see, if we browse inside the project, Unity has created its own needed files and folders. Next important step is configuring the project to use DirectX 9. DirectX 11 is used by default in the latest versions of Unity. DirectX 11 is yet not supported by NoesisGUI. Although the latest beta is already compatible with DX11, this step won't be needed in the future. And next, we import the NoesisGUI utility package. In this case, we are using the latest version, 1.1.9. This process takes several minutes. I will pause the recording and continue after that. Once we have imported the package inside Unity, our working environment is ready. What we are going to do is using Blend to design the interface, and each time we save, we will go back to Unity to see the results. The first step is creating a folder where we are going to store all the resources. We are going to call it Tutorial, and we are going to create a XAML. We create a new item. In this case, we are going to create a user control. Let's name it Test XAML. Good. Once created the Test XAML, let's switch to Unity to verify that it detected our changes. And we can see that there are several errors in the console due to a C# file created by Blend. This file is the code behind of the XAML. It is generated automatically by Blend. We are not going to talk about code behind in this tutorial. We can ignore it, or yet better, delete it. And very important, we have to remove the reference to the class inside the XAML. Having done this, let's create a background to verify that Unity renders it correctly. A blue, for example, with a gradient. Something like this. Well, we save and switch back to Unity to start creating the scene. To that end, and as the user interface is going to be in the camera, we create a component in the camera with type NoesisGUI panel. This panel has a field where we can drop the desired XAML. We are going to drop it now. The style is left by default. The quality is improved by selecting PPA because we are not using multi-sampling right now. The tessellation quality is also improved a little bit. Let's check if the renders is correct. Let's hit play. There we have it. Good. We can continue with the user interface in Blend. Let's create a circle, for example. I am adjusting the X and Y to really create a circle and not an ellipse. And let's improve the aspect. Let's use a radial gradient on the circle. Let me adjust the stops of the ramp. To get volume, let me change the origin and position of the gradient. Okay, we got it. Save and back to Unity. Perfect. Although there is a little problem. If viewpoint dimensions are changed, our user interface does not scale properly. This is due to the fact that we are using a grid container. We have to use a container that scales properly. For that, let's use the view box, that is the container in WPF, in charge of resolution-independent user interfaces. Let's group or route, a grid in this case, into a view box. And let's say to this view box that stretches itself uniformly, maintaining the aspect ratio between X and Y. Let me save, back to Unity, and as you can see now, it scales properly. NoesisGUI is a vectorial user interface. One advantage is that pixel-perfect interfaces are always displayed independent of the resolution. For example, let's maximize on play. As you can see, the circle is always displayed perfectly. Good. The next thing I want to do is create a button that animates the circle when it is clicked. Let's go to the palette, select a button, and create a big button. Let's make the font bigger. OK. Save. Unity. There we have it. As you can see, the aspect of the button is a little bit different from Blend. This is happening because the default style used by NoesisGUI is different to the one used by Blend. Now, let's create the animation we want to shot. For that, we need to create a storyboard. I'm going to name it Animation. What it is going to do is, let's create a default key at time 0. And for example, at time 0.5, the circle goes up. And at time 1, it falls to its original place. Let's see. To improve the quality, let's change the interpolation of each keyframe. For example, a sign out for the first key, and a bounce for the last one, with 2 bounces. Let's see. Perfect. Save. Unity. By default, the sphere starts with the animation. Why? Because Blend by default added the storyboard to the onload trigger. As we are not interested, let's remove it. We want to trigger the animation by code. Having done that, let's create the script in charge of the logic. To that end, let's create a C# called text and attach it to the camera. Fine. Let's sync the Mono project and open it with Visual Studio. Let's open our text.cs. Format it, and start with the logic. First thing is activate the namespace Gnosis, under which all the NoesisGUI API is under. And let's create the member variables we need. The root, that as we can see in the XAML, is of type user control. And we also need the animation whose type is storyboard. Having done this, let's start. Let's take the component we assigned to the camera, the NoesisGUI panel. And let's take the root. How? Using the getRoot, passing the type, in this case, user control. With this, let's find the animation. The animation is found using the root, also using the function findResource. The type is storyboard, and the name is the one we gave in the XAML. If you remember, it was animation, that is stored in a resource directory. Now let's go for the button. It can be taken from the root also. Let's use findName. We have to provide a name. Which one? Let's go to Blend. Select the button, and you will see that it has no name. By default, elements created by Blend are unnamed. Let's name it Button. As you can see, this creates an x.name entry in the XAML. I got the button. Now I want to get connected to the click event using a delegate. And inside our handle, we launch the animation on the root. OK, let's verify that the script compiles correctly in Unity. Let's see. No errors. Let's test everything. There we have our circle bouncing. Good. That is all for this tutorial. We created a very simple user interface. You can continue using Blend to create more complex things. Thanks for watching this tutorial.